Hello and welcome. In this video, I'll give a brief overview of user-defined functions in TDengine 3.0. TDengine has full support for standard SQL and even includes extensions to SQL for time series data. However, there may come a time when you need a function doesn't exist in SQL. In that case, you can code your own function and import it into TDengine as a UDF, user-defined function. On the documentation here, we can see that TDengine supports user-defined functions written in C or C++, and they can be scalar or aggregate functions. All the requirements for creating your function are given on this page. I won't go through them one by one. Instead, I'll use the sample code at the bottom to show you how to import it and use it in TDengine. There's a sample function here for a bitwise AND. This is a scalar function. And to get this into our TDengine, first we will copy the code to our local machine. We can see that it's here. And then we'll compile it as a library. Under compile UDF, there's a GCC command that will compile it for us. Once that's done, we need to import it into TDengine. When you import a function into TDengine, you must use the TDengine server itself. You can't use the REST API to do it remotely. Once you have imported it, though, you can use your UDFs from any system. So to import it, we'll go into the CLI on the server, which is Taos, and use the create function command to put it into our system. The syntax is pretty simple. Just create function and the name, which we'll call bitAnd, and then as the full path in quotation marks, and then output type. You have to specify the data type that will output, in this case integer. Once you've created, we can do show functions to list all the UDFs in your TDengine deployment. In this case, just one, the bitAnd function. Now, to prove that it's working, I created some sample data in a test database. And I'll show that data first. So you can see two columns here with just some integers in each one. And then we can use the bitAnd function that we imported like any other SQL function. We'll just do select bitAnd and then column 1, comma, column 2 from UDF table. And we can see that it's performed bitwise AND on the values in each column. And if you use a bitwise calculator, you can prove that bitwise AND of 1 and 2 is 0, 2 and 3 is 2, and 5 and 6 is 4. I hope this has been helpful for you. If you enjoyed it, please like and subscribe, and we'll see you in the next one. Thanks.